Hello, my name is Ross Nakatsuji, and I'm the product manager for Headwall's remote sensing systems. Today I'll take 5 minutes and speak about our solar-induced fluorescence imaging sensor. As many of you know, Headwall has been a leading hyperspectral imaging sensor and systems provider to researchers, organizations, and companies for many years. We're well known for our UAV-based defense and industrial imaging systems, but along with those is an application-focused sensor that we designed, build, and sell for manned aircraft and terrestrial use. We call it the Solar-Induced Fluorescence Imaging Sensor, and it is among our high-end hyperspectral imaging sensors. Many of you are far more qualified than I am to explain and elaborate on the so-called SIF or chlorophyll fluorescence phenomena. But for those who are new to the topic, I'll give a brief overview here. The first recorded observation of SIF was made almost 2 centuries ago when Dr. David Brewster discovered that a beam of sunlight striking a green alcoholic extract of laurel leaves elicited a brilliant red light. Stokes later coined the term fluorescence to describe this phenomena in general. Remote sensing of solar-induced fluorescence is rapidly advancing as a technique in agriculture and environmental science. Although it's founded upon decades of research, applications, sensor developments in both active and passive sensing of chlorophyll fluorescence. SIF can be assessed remotely using high-resolution spectral sensors in tandem with state-of-the-art algorithms to distinguish the emission from reflected and/or scattered ambient light. Two photosystems are involved. Photosystem 1, which emits mainly in the far red, and Photosystem 2, which emits in both the red and far red regions of the spectrum. Plant reactions to stresses result in changes to the fluorescence emission and reflect a complex relationship between fluorescence and carbon assimilation. Many plant health, plant stress measurements report on latent effects where damage has already been done and beneficial factors have disappeared. Photosynthesis is a key process, and measurement of this in near real or real time is crucial to understanding mechanisms that are harming or helping vegetation. That's where SIF comes in. Many symptoms can be detected before they become visible using other means. You can see that many research topics can benefit from SIF data. This table was created using material in a very detailed and influential paper published in Remote Sensing of Environment by Elsevier in 2019, edited by Jing M. Chen, entitled Remote Sensing of Solar-Induced Chlorophyll Fluorescence, SIF, in Vegetation, 50 Years of Progress. I highly recommend that you download and read this because it provides not only an overview of the topic, but also information on instrumentation and analysis techniques that have been and are being used today. So, SIF is a comparatively weak signal that competes with the sheer amount of solar radiation coming from the sun, atmospheric effects, center characteristics, as well as observation angle. Sensors from handheld to tower and drone, manned aircraft, and satellite exist. Most are not necessarily meant for high spatial resolution imaging, but rather measurements at a point on a leaf or of a small area. Speaking of satellites, the first satellite specifically designed to measure SIF is currently due to launch in mid-2024. The ESA FLEX mission will use a high-resolution fluorescence imaging spectrometer that is very similar in design to Headwall's imaging sensor, and many organizations have deployed or plan to deploy SIF instrumentation to complement what FLEX will provide from orbit. So, with input from customers, Headwall designed and built a high spectral and spatial resolution sensor 4 years ago that won the 2019 OSA Team Engineering Award that quite coincidentally is named after my former boss when I was product manager at Cambridge Research and Instrumentation and later PerkinElmer. You can see that the extraordinarily high spectral resolution of our SIF imaging sensor captures the very fine detail that is required for this application. Without this very high spectral resolution, the sensor simply would not work. Performance was validated using NASA Goddard's Glamour, and then a sensor was deployed as part of the G-Lite platform over test fields and vegetation in places like Puerto Rico. The first batch of SIF imaging sensors have been delivered, and customers are lining up for the next batch of sensors that we're building right now. In addition to airborne systems, environmental monitoring towers are candidates for these sensors, also pointing downward and capable of long-term imaging data capture of subjects like forest canopies. Thank you very much for watching this presentation on the Headwall Solar-Induced Fluorescence Imaging Sensor. That's all the time I have, so if you'd like to know more, please reach out to me. Thank you once again, and please stay safe while you work on your research.